Hi and welcome to my presentation titled Anonymization is Dead, and here's why. My name is Paul Nelson and I'm a PhD student at Chalmers University of Technology working on data privacy. I'm guessing you might have signed up for online services that require you to read a user agreement document before you can create an account. Now, did you ever stop and actually read what that user agreement said? I mean, let's face it, these user agreements are often long and difficult to understand. And somewhere in these documents, hidden among all the other text, is usually something on data collection. That is, what they will do with your data once they collect it. So usually they'll write something like, we'll give you anonymization, or even 100% privacy. Have you ever stopped and thought, anonymization, what does that mean? If yes, great. If no, also great. You may learn even more from this presentation, because the topic I want to discuss with you today is anonymization. So, what is anonymization really? Well, it's this idea that someone will collect your data, then scramble it around in some way. And once it's been scrambled, it shouldn't be possible to link that data back to you. However, the scrambled version of your data should still be close to your actual data so that we don't just generate garbage. That way, analysts can still use your data without being able to link it back to you. So let's use an example. Let's say you're age 32, but instead we'll scramble your age to 30, or maybe even the range 30 to 35. Then the scrambled version, that is the anonymized version of your data, should not be possible to link back to you. Seems pretty neat, right? The problem is, it doesn't always work. And what's worse, it's really difficult to know if it's going to work or not. In several real-world examples, what was believed to be anonymized data has later been linked back to individuals. That is, in some cases, anonymous data can be de-anonymized, meaning that the data is no longer anonymous. So while we're at it, let's look at some of those real-world examples. The first example is usually referred to as the governor of Massachusetts. And why? Well, because it involves the man who was the governor of Massachusetts at that time. So what happened was that the state of Massachusetts had to gather and store medical data. Nothing unusual about that, but the governor of Massachusetts had the brilliant idea that what if we anonymized this medical data? Then we could safely release it without accidentally being able to identify anyone in that data set. Okay, so what was actually in this medical data set? Well, there was the social security number, the name, the ethnicity, the date of birth, sex, zip code, marital status, and then the problem that patient had. That is, the medical problem that was the sensitive information. So, how does one anonymize this kind of data? Well, what they did was that they removed the parameters that are obviously identifying a person. In this case, the social security number and the name. So the big question is this data then anonymized? Well, on its own, it's not really a problem, but the problem here is that there was other data available. In this case, LaTanya Sweeney, who performed this de-anonymization, could purchase a voter registration list for only $20 with some additional information in it. In this voter registration list, the parameters were the name, address, city, zip code, date of birth, sex, and party that one votes for. So you may have already noticed that some of these parameters were actually available in both of the data sets. So those parameters, in this case, the date of birth, the zip code, and the sex were available in both data sets. So what LaTonya Sweeney did was that she wanted to find actually the governor of Massachusetts himself in the medical database to show that there was in fact a problem with this kind of anonymization. So since the governor obviously was in the voter registration list because he wanted to vote for himself, Sweeney entered his date of birth, his zip code, and his sex to see how many matches she could find. And it turned out that in fact the governor of Massachusetts was the only one with this unique combination of those parameters. So by finding William Weld, the governor of Massachusetts, in the voter registration list where the name was available, she could later on correlate this record to the medical record to find the anonymized version of William Weld also in the medical database. So even though the name and the social security number of William Weld had been removed from the medical database, since there were other data available, LaTonya Sweeney could still identify him in this supposedly anonymized version. So basically, it didn't work. A similar example of accidental de-anonymization involves Netflix and the Internet Movie Database IMDb. What happened was that Netflix wanted to improve their recommendations for what to view next, so they actually launched a challenge where analysts could download an anonymized version of Netflix's users' ratings for different movies. So essentially, it had been anonymized in the same way as the previous dataset we saw. That is, they just removed the usernames from the dataset. Again, this kind of anonymization at first seemed pretty good. But again, there was a problem. Just like before, there was a second dataset that could be used to de-anonymize the Netflix data. And the reason this could be done is because it turns out that not a lot of users have viewed all movies in one movie service, which means you will only have ratings for movies you've actually seen. So just think about that for a second. Do you think anyone has seen the exact same combination of movies that you have seen? And what's more, do you think they would all give the same score to each movie that you would? So that's unlikely. In this case, it was possible to use the Internet Movie Database, IMDb, to correlate between the Netflix set and IMDb to find users in this so-called anonymized set, just like in the previous example. Why is it so difficult to anonymize something properly? Well, the problem is we don't know what other data is out there already. And we also don't know what other data will be out there in the future. Because of that, we actually don't know what to protect ourselves against. Essentially what I'm saying is we don't know which part of the data can be used to identify us later on. So reasoning about what part of the data is sensitive and which part isn't really doesn't make sense. Instead, we'd be better off just categorizing all data as potentially sensitive and protect all of it. But then we can't use the same technique that we've been using before, where we just removed the sensitive data, because, then there would be no data left. What if there was some kind of thing that could guarantee privacy even in events that we couldn't foresee? For example, an entirely new database with lots of information about me being released. Actually, there is such a thing. And it's called differential privacy. Instead of trying to determine which part of the data is sensitive and what to remove, we just treat everything as sensitive. And then differential privacy will tell us how to scramble our data for it still to be useful and also still private. So how is differential privacy different from standard anonymization? Well, anonymization looks at your data and determines what to do with it. Instead, differential privacy looks at the function you want to compute. For example, which movie has the most views on Netflix could be a function. And then it determines how should I scramble this function and not how should I scramble your data. In the end, differential privacy is able to give you mathematical guarantees on privacy. So unlike all of those that promise you anonymization or 100% privacy, differential privacy can actually put a number on your amount of anonymity or privacy. Therefore, it's much more exact than other methods. Keep in mind, anonymization isn't a technique, it's just an idea. So the next time someone tells you they'll anonymize your data, you'll be able to ask some of the following questions. First up, what do you mean by anonymization? And secondly, how do you achieve anonymization? Or even, what techniques are you using to anonymize my data? If the data collector can't or won't answer these questions, well, that's a red flag. So stay safe and inquisitive. After all, it's your data, and you deserve to know that it's being handled in a way that you're comfortable with.